graphing y equals 2 cos pi x plus 1. The general equation for cosine function is y equals a cos open bracket bx minus c close bracket plus d. So the first point to do, to carry out, is to find the amplitude. If you have a general y equals cos of x, and if we sketch that graph, the graph starts at 1, comes down to 0, and go all the way to 1, and then go back down to 0, and then back to 1. So this is 0, and this is 2 pi. So that's a complete cycle. That's one period. And this is plus 1, and here is minus 1. So the amplitude here is plus 1. It's from 0 to 1. So it's actually 1, the amplitude. So the amplitude of the function we are plotting is 2. The next thing to do is to find the period. And period is 2 pi over b. In this case, the period is going to be 2 pi over b, but b is 1. So 2 pi over 1 is still 2 pi. In our case, the b here is pi, because that's b here, and that's b there. C is 0, and d is 1. So we write 2 pi over pi, and that becomes 2. So the period for this function is 2. Number 3, we have to find the x scale, that's the quadrant, and that would be period divided by 4, because every cosine function and sine function has 4 quadrants. The first quadrant is 1, 2, 3, and 4. So we divide the period by 4, and that will be 2 divided by 4, that equals a half. Number 4 is we take the start of the period and the end of the period. The start of the period here is you set x to 0. So that's the start of the period. At the end of the period, you set x to pi. We don't have x, we have pi x. So we set pi x to 0, and therefore x equals 0, because if we divide both sides by pi, x would still be 0. For the end of the period, we set pi x equals 2 pi. So if we divide both sides by pi, x equals 2. So number 5 is, do we have a vertical translation, which in this case is plus 1. That meant y equals 0. In this case, this is plus 0. So in this case, that meant y equals 0. So that's why it's lying on the x-axis. X-axis is y equals to 0, and y-axis is x equals to 0. This curve is lying on the x-axis because the constant is 0. So therefore y equals to 0. Let's just write it here. Y equals to 0 for the x-axis. So that's the x-axis here. So right, we're going to plot the values now. So we've got the graph. The start tells us what the x-axis should be, so it's 0, and the end tells us what it should be as well. So we should be plotting 0 to 2, right? So that's why we've got 0. And we calibrate it by a half because this is telling us we're adding a half to 0. Then next one, another half, another half, another half. So that's why we have, the scale is telling us what to do. So we have 0, a half, 1, 3 over 2, 2. Likewise, minus a half, 1, minus 3 over 2, minus 2. This graph is going to be raised because it's plus 1. So it's going to be raised by 1. And so I'm going to draw that. Right, so it's going to be raised by 1. So which means that it's lying on y equals 1. So it's going to lie on y equals 1, not y equals 0. This is y equals 0. So now we need to plot the point. This is a parent function graph. Now this is the function we're plotting. The amplitude is 2. That means the height between the resting point, our resting point is 1. And so we have to add 2 to that. So that's the amplitude. So it's going to be 1, 2. So it will be 3. Now, because it's a cosine function, so that's why it's good to know what the parent function looks like. It's a cosine function. At 0, x equals to 0, it will be starting from there. Because 2 is being added. 1, 2. That's the amplitude. And then it will come down. We add a half to 0, so that's it. And that will come down. And then we add another half, 1. It'll go down 2, so that will be 1 and 1, so it will be minimum there. So that's the maximum, that's the minimum. At 2 here, it will go back to 3 here. So that's the oscillation there. But what has happened is we don't have the scale of pi, we only have the scale in numbers because we had to divide by pi. So this is a turning point here, and that graph will, that point will go up there to meet that point. And likewise, this is a turning point, so it will come down, meet that point there by drawing. Always use pencil to draw your graph. Right, so that's the first period. So we could now plot the second period on this side. This is on the negative side of it. This graph is periodic, and it's continuous. So that's the first period. We're going to plot the second period. Second period, obviously, will start from there, and it come down to here, minus 1. Sorry, y equals to 1. And then from there, you will go down to minus 1 here. So we come down to, from there, come down to minus 1 here. That's the minimum there, like that one. And back to 3 there. So we know this graph is turning there, and it's also turning there, so it's going to join that point over there. And likewise, this one will be turning there. And then going on to join this curve here. So that's the curve. So I've just plotted 2 period. As you can see, there is translation here. That's the translation there. And the curve itself, it's same as cos x, except that it's been translated by 1. So always find amplitude and the period, x scale, that tells you how to divide the 4 quadrants, the start of the function and the end of the function. Check if there are any vertical transition, which in this case there is. Y equals 1, not 0, 1.